Hello everyone, welcome to this video. We are going to discuss the following topics in this video. Pure couple. Concurrent forces. Changing the reference point of a force system. These topics are very important because they are used to understand the force systems applied to objects. The analysis of force systems is fundamental to understanding the state of a particle or rigid body. We can also use these concepts to solve statics problems. Let's look at the particular case of a pure couple. Imagine you have a rigid body. And there are two forces applied to this rigid body. Let's put some conditions on these forces. First of all, the two forces have the same magnitude. Secondly, they have the same orientation. In other words, their lines of action are parallel. And lastly, they are in opposite directions. We can show these three conditions in this single equation. We can also assign a value of F for the magnitude of both of the forces. With these conditions met, the moment that these two forces create around any points in the plane is going to be F multiplied by d, where d is the distance between the lines of action of the two forces. Remember, the reference point can be anywhere in the plane. Whether here, or anywhere else. The concept of a pure couple is important because in practice it is the main method used to create pure moments in mechanical systems. A simple example of a pure couple is when we use a four-way lug wrench to fasten or loosen a bolt. When we are using both hands to apply forces at the two ends of the wrench, assuming that the magnitudes of the forces are the same, we are forming a pure couple. Assuming that the length of each of the wrench's arms is a, the moment resulting from the pure couple has a magnitude of 2 multiplied by a, multiplied by F. Now let's look at another special case, where we have several forces applied to a rigid body. In this scenario, the forces are in different orientations and have different magnitudes. But the line of action of all the forces passes through one single point. This type of system of forces is known as concurrent forces. For a rigid body under concurrent forces to be in equilibrium condition, we need to only satisfy the force equation because the forces do not create any moment around point O. For the last topic, let's talk about the concept of changing the reference point. Assume we have a rigid body. A force, F, is applied to this body. We can transfer this force to another point. Let's say point O. During this transfer, however, we need to make sure to consider the moment that this force creates around O. So we need to place a moment at point O, with a magnitude of F times d. D is the normal distance between the line of action of F and O. It is important to notice that the two force systems that we have here are equivalent. It means that have the same effect on the rigid body. Because the total forces applied in both cases are the same. And the total moment applied in both cases is the same as well. Let's look at an example to better understand the utility of changing the reference point. Assume you need to use a wrench to fasten or loosen a bolt. You are using one hand to apply a force to the end of the arm of the wrench. We can transfer this force to another point, let's say a point on the main axis of the bolt. We call this point O. In effect, the force system that we will have in reference to point O will constitute a force F and moment M. Assuming the length of the arm of the wrench is A, the magnitude of the moment is F times A. This means that a transverse force with magnitude F and a moment with a magnitude of M around the main axis of the bolt is applied to the bolt. This force and moment can be used to analyze and design the bolt. Note that if another point in the bolt is chosen as the reference, the magnitude of the moment can be different. We might also see moments in other directions. Thanks for watching this video. Please hit the like button and subscribe if you liked the video. Please leave a comment and share your opinion about this video.